Evidence of Evolution, Part 1. Our learning goals for Part 1 are to explain the evidence for evolution using the fossil record, homologous structures, analogous structures, and vestigial structures. First thing we're going to talk about are fossils. The way the fossil record can be evidence of evolution is that if we find fossils that show transition between two species. In other words, if we find fossils that are an intermediate between two species, that can be evidence of evolution. Let's watch a movie about whale evolution.
Gingrich's early interest in primitive land mammals eventually took him to Pakistan. It was there that he made the kind of find most paleontologists only dream about. A fossil that would rewrite one of evolution's greatest stories.
I found the back of a skull that I couldn't identify. It had a very good, well-preserved ear region, and that offered the clue to what it was.
The shape was familiar, but in other ways it was like nothing Gingrich had ever seen.
This is the original specimen. It's the one we found in about 1978. There are several things that strike you. One is it's very similar in size and shape to the back of a skull of a wolf.
But there was something odd about this skull. On its underside was a walnut-sized bump.
If this wasn't here, I would think that this was an archaic carnivorous mammal, what we call a creodont. But it is here.
It was part of the animal's inner ear, and it had a distinctive shape. A shape found today in only one kind of animal: whales. What was the ear of a whale doing on the skull of an animal that resembled a wolf? Gingrich was intrigued, so he constructed a model of what the creature's full skull might have looked like. He wondered, was his find a crucial missing link? The first fossil evidence ever found for one of Darwin's most daring claims, that whales had evolved from land mammals. To know for sure, Gingrich would need to find more fossils. Ones that would show each stage of the whale transformation, what scientists call transitional forms.
I want to line them all up. I want anyone to be able to see it and believe it because they've seen it.
Basilosaurus, a 40-million-year-old creature already known to science. Basilosaurus lived full-time in the water. If whales had evolved from land mammals, they had done so long before Basilosaurus. So Gingrich didn't think the bones would be of much interest. But he couldn't have been more wrong. After only a few days of digging, he made his second amazing find. It turned out that Basilosaurus had something modern whales have long since lost.
For the first time, we've got whales that have legs.
The bones were small but unmistakable. A pelvis, a kneecap, even toes. This whale had a complete set of leg bones. Gingrich brought back as much of the skeleton as he could carry. It was dramatic evidence that whales had once been four-legged animals. Since Gingrich's finds, he and others have filled in more of this fantastic story. Scientists now think that the earliest ancestor of whales was similar to this 50-million-year-old wolf-like mammal called Cynonyx. Cynonyx was a predatory scavenger that lived and hunted along the shores of an ancient sea. Perhaps its descendants found the water a source of abundant food and a haven from competition. Over millions of years, front legs became fins. Rear legs disappeared. Bodies lost fur and took on their familiar streamlined shape. Since Gingrich's first find, named Pakicetus, the list of known transitional whales has grown. It now includes Ambulocetus, Rhodocetus, Durodon, as well as Basilosaurus. They reveal another element of whale evolution, the gradual migration of nostrils to the top of the head as whales adapted to breathing in the water.
How did whales lose their legs?
As the years went by, they evolved into newer types of...
Gingrich's work demonstrates what Darwin himself insisted, that the evidence for evolution is all around us if we choose to look for it.
So here we're going to look at some of the fossils that were talked about in that movie clip. This is one of the first ancestors of the whale, and you can see that it looks pretty dog-like. If we look at another transitional fossil, we see that the body has become more streamlined. It's developed a very powerful and muscular tail. The front legs are still present and pretty robust, but the back legs don't look very useful. It's obvious this animal was not walking on these rear legs. Here's Basilosaurus that was in the film clip. You can see the front legs now are obviously flippers, and the back legs are just a vestigial structure. Here we can line up these transitional fossils from Pakicetus all the way through to Basilosaurus and all the way to modern whales. This is very strong evidence of evolution. Body structures can be evidence of evolution also. Homologous structures are structures that have very similar form and develop from the same embryonic tissues but have very different functions. Let's look at some examples. The human arm, the mouse front leg, and a bat wing all include the same bones. These bones are all the same bones, but they obviously have very different functions. The human arm is made for grasping, reaching, holding. The mouse front leg is made for running, and the bat wing is made for flight. But all these structures develop from the same types of embryonic tissues and have the same bones. Analogous structures are also evidence of evolution. These are structures that have very different structure but very similar function, just the opposite of homologous structures. And here are some great examples of analogous structures. The bird wing, the butterfly wing, and the bat wing all perform the same function, and that is flight. But the three of them are made entirely differently from entirely different structures. So homologous structures are similar structure, different function. Analogous structures are different structure, similar function. Vestigial structures are evidence of evolution because they're structures that are present but no longer used. Let's look at some examples. How about wings on flightless birds? What use does an ostrich have for wings, and yet it has wings? Pelvic bones in whales. Whales have pelvic bones, but they don't have pelvic limbs, back legs. What use are they? Humans have tail bones, appendix, and ear muscles. We have tail bones, yet we have no tail. We have muscles that are used in other animals for moving their ears, but we can't move our ears. We can't swivel our ears like cats and dogs do. And we have an appendix. It's a tiny little structure now, but this structure is used in other animals to digest large amounts of plant material. A horse has an appendix that's 4 feet long. Vestigial structures are structures that were used at one time by an ancestor species, but their function has been lost to us, yet we still have the structure.